Welcome to this Spring tutorial from in 28 minutes. Before we look into the specific topic at hand, let's get an overview of what we are trying to do at in 28 minutes to make learning Spring easy. We have a repository on github.com/in28 minutes, Spring in 28 minutes. The link you'd find below the video, where we have all the code examples that we are going to discuss now. All those are present in the Git repository. So if you go to Spring in 28 minutes, there are a lot of example Maven projects which would help you learn Spring very easily. We start with simple examples and discuss things like JDBC, aspect-oriented programming, MVC, and all that kind of stuff. You should find examples in here. If you go further down, you should also see how you can install these examples which are used in this particular tutorial. So you can click this link, takes you to a video which shows how you can install all the code that you would need to be able to run all the examples that we would discuss now. Let's now get started with the specific topic of this particular video. As we said earlier, the entire code is in GitHub in the repository in 28 minutes. The URL is github.com/in28 minutes. You'd find it below the video as well. And in here, we are now learning Spring. So you can click Spring in 28 minutes. That's the tutorial that we are looking at right now. You'd see a number of examples. So you'd see around 5 different projects and a couple of PDFs also in here. If you don't have Java, Eclipse or Maven installed, you can use this installation guide. The installation guide will help you set up Java, Eclipse and Maven. And there is also a link to a video which can help you further. If you are familiar with Git, then probably you can use your Git client to get this code from here. If you're new to Git, the easiest thing to do is to do a download zip. So go here, click download zip, and you would have a zip file with the entire content of this particular Git repository in your local. And you can unzip whatever comes up to a folder. What I have done is unzipped the code to Spring in 28 minutes, and you would see a structure similar to whatever we saw in GitHub. So you see first example, the basic example. These are other examples which we'll be talking about. So we will start with the first example from here. Let's take a quick look into what code is present in the first example. Actually, there is not a lot of code in here. There is just basic setup information which would help us quickly get set up and running with Spring. So what we have in here is all the folders are empty. So inside the source, there is nothing. A pom.xml is the file which is used by Maven to track dependencies. So to run our examples, we need Spring. So pom.xml contains a link or a dependency of Spring. So if we look at the pom.xml, there are a few dependencies defined. So I have a dependency on Spring Core, Spring Context, Spring Beans. So these are different jars which are related to Spring, which we would need to be able to run Spring applications. So the Maven pom.xml helps us to manage these down and download these whenever we need them. So instead of manually going and downloading the Spring Core, Spring Context, Spring Beans, we would be using Maven, and we'll ask Maven to download them from the repositories and make them available for us. So this is pom.xml, and you would also see that we are using a log4j because we want to see the log as well. So we use a log4j, and there are a couple of test dependencies. So the pom.xml is quite simple one. We just define what are the Spring dependencies that we would need. The log4j.xml is there so that we can see what log is generated. When the Spring framework runs, it generates a lot of log. And if we are able to look at the log, we'll be able to understand what's happening in the background of Spring very easily. The first one is pom.xml, contains the list of dependencies, the list of jars that we would need to run this project. The second file, log4j.xml, contains the logging settings. So what happens when the project runs? What kind of log is generated? So these two are something which you don't need to worry about at all. These are quite simple and we are not going to touch them during this tutorial. So these two files, we can forget about them. The important file is the to-do business test. The to-do business test, if you look at it, it has about 20 lines of code. Most of it are imports and packages. It basically has a simple context, simple Spring context defined so that we are able to run a unit test. We will understand the exact annotations which are used in here in the next sections of this particular tutorial. But for now, we would just assume that these things would work as they are, and we would start with our first example. So basically what we have is just three files with very less information, which would be helping us to get started very fast. When I launch up Eclipse, it asks me for a workspace. Select some folder in your local hard disk and probably end it with a folder something like Spring Tutorial and press OK. Eclipse launches up and it shows this particular screen. So what I want to do is import the project that we have downloaded. So we downloaded a zip and we unzipped it to a folder. So we would want to import that particular project. So how do we do that? So that's file, import, and type in Maven because we want to import a Maven project. So what I would say is existing Maven projects and click next. And in here, browse to wherever your first example is. So the folder which we actually downloaded called Spring in 28 minutes. This is the complete zip. But the project which we want right now is 0.firstExample. So I'm putting it in here. You can also browse to it. So you can click browse and kind of select the project that you want to import. So once you click finish, it will take some time because Maven has to work its magic in the background. It downloads the dependencies and makes them available for the project. And you should see everything in a few minutes. We are all set. This is the folder structure I see when I import the project for the first time. So as you can see, there are no Java classes, there are no resources, there are no test files, and there are no test resources as well. All that we have is a pom.xml, a log4j.xml, a to-do business test.java, and to-do business test final.java. The to-do business test final is more is the complete example code which we would have by the end of this particular tutorial. So you can ignore that. So the three important files are log4j.xml, pom.xml, and to-do business test.java. And what I would do is I would move this file log4j.xml. So the log4j.xml, I would drag it and I would move it to source test resources. I need the log4j.xml. When I'm running tests, I want to see the output in the console. So I will drag it and I will move it to log4j.xml. That's very good. The to-do business test.java, I would want to move it to source test Java. So I'm dragging it and moving it to source test Java. It is showing a few compilation errors. We'll fix them soon. So when I go into to-do business test Java, it is showing a compilation error. It's saying does not match the expected package. So what I would do is I would click here and it offers me two suggestions. I would want to use the package com.in 28 minutes. So I would say move to do business test.java to package this. And you would see here that the entire package structure is now created. So com.in 28 minutes.spring.example1 and the to do business test is copied over to that particular folder. So we now have the test setup and we have the log4j setup and we have the pom.xml which is working. You'd see that all the Maven, all the jars which we need. So you'd see that the jars which we need are downloaded by Maven automatically. So Spring Core, Commons Logging, Spring Context, Spring UOP, all these jars are automatically downloaded by Maven and made available to us. And that's the magic of Maven. We don't really, as long as we are mentioning the right dependencies in the pom.xml, Maven does the magic for us. It gets these dependencies and makes them available to us so that we can focus on writing Spring code. So as you can see, within 5 minutes, we are now ready with an example project setup, and now we can focus on learning what a Spring framework does. I'll do a right click on the test and say run as JUnit test, and you see that the JUnit test is running. So it's green. That's perfect. So it means everything is properly set up, and you would see a lot of log also being generated. We'll look at this log in detail a little later. So we are all set to learn about Spring. Are you ready? Let's get started with a real example. The real reason why Spring is very famous is the thinking behind the Spring framework. Things like dependency injection, the architectural flexibility it brings in. So we take a practical example to illustrate that. Let's look at the problem we want to solve here. We are developing the business layer of a web application for task management. That is, we manage to-dos of different users. The architecture of this application is very simple. You have a web layer, business layer, and a data layer. The data layer gets the data from the database. The business layer applies business logic on it. We want to develop a very maintainable application. So we focus a lot on our tests. Our current task is to write the to-do business service in the business layer. The to-do data service is returning all the to-dos for a particular user. So let's say a user has 15 different tasks, 15 different to-dos. Then the to-do data service is currently returning all those 15 back. But what I want to do is to create a method in the to-do business service which would only return the tasks which are related to Spring. So that's the first example which we would create. So basically we want to write the business logic in here to do the filtering of the to-dos and only return the tasks which are related to Spring. Okay, then let's get started and get our hands dirty. During the initial part of this course, we would write a number of classes in the same file. That is to make it very easy to see and change things. And as we move further, we would actually separate them into separate classes. Another important thing to note is that in the code that you have downloaded, there is a file called to do business test final.java. This actually contains the code at the end of the example that we would be discussing now. So if you find me typing somewhere very quickly, or if you're not able to follow exactly what's happening in this tutorial, you can actually go download that particular file and probably take that particular section of the code and use it. So let's say I'm implementing this particular thing and you are not able to directly see what's happening there. You can directly copy and paste it in your code and you would be ready and set up. So let's create our first class now. So we were talking about a to-do data service. So let's create a to-do data service. So to-do data service, and what we want the to-dos data service is to get the to-dos from the database. So I would want to return a list of strings. Those are the list of to-dos. I'll call it retrieve to-dos. I would want to pass a parameter user because I want to get it for a particular user. And let's say I have a class data, and this kind of has a static method. This is not really a good implementation of the whole thing, but I just want to quickly get a example of to-do data service so I can get started with the to-do business service, which is really my task at hand. So I've quickly created a database class which is retrieving the list of to-dos for us, and I'm returning learn Spring, learn struts, and learn to dance. This is very simple implementation. It uses arrays.asList and returns this back. Now the to-do data service, let's just say it gets the values from the database. So it returns database.retrieve to-dos for that particular user and returns them back. So what we have done until now is we quickly created a to-do data service, which actually talks to a static method in the database. This is not really a database connection, but in the first example, I didn't really want to complicate by having a real database connection. So let's assume that this is like a real database. Let's assume that this is really a database and it's returning the values from the database. So now we have a to-do data service which is having the retrieve to-dos method and which is returning the to-dos for a particular user. So let's focus on the class that we would want to create. The class which we want to create is the to-do business service. So I'll start creating a to-do business service. As we discussed earlier, to-do business service needs to-do data service. So to-do data service is the one which gives the data back. So I'll call it data service is equal to new to-do data service. Now, I would want to create a method for retrieving the list of tasks which are related to Spring. So I would say retrieve to-dos related to Spring for that particular user. The basic implementation, I can just use the data service which we have created and say retrieve to-dos for that particular user and return these back. But the problem is this particular set of to-dos that we have is the complete list. We only want those which are related to Spring. So what I'll do is I'll create a temporary list where I will store only the ones which are related to Spring. So I'll create a new array list. What I'll do is I'll get this into a local variable and I'll loop around them. So I'll say I would want to call this to-dos. So now that I have the to-dos, I'll loop around them. So for string to-do around to-dos, if to-do dot contains, I will add it to the list to-dos related to Spring. To-dos related to the Spring dot add to-do. So what we are doing essentially here is we are filtering out those ones which are related to Spring and returning it back. So this is how the typical web application layering would be. So you have a data service which is talking to the database and getting the complete list. So you are getting this data service might be talking to a database, might be talking to an external service or anything like that. So this gets the data from the database here. And the to-do business service has methods which apply business logic around the data which we get from the data services. So the data service gets the entire list of to-dos, but the user interface, let's say I'm only interested in those things which are related to Spring. So if the to-do contains Spring, I would want to put it in the list. So this to-dos list would be returned back to the particular calling method. So this is how the application development was done in earlier days, where we actually, so if I need a to-do data service, I would directly create an instance of the to-do data service inside the method and return it back. The to-do data service here, the data service here is called a dependency. So the to-do business service needs to-do data service to do its work. And so the data service is a dependency for to-do business service. So the to-do business service is dependent on the data service to get its data. So without the to-do data service, the to-do business service cannot do its work because the to-do business service has the business logic, but who gets the data for it? The data is got by the to-do business service. Sorry, the to-do data service. So the to-do data service is the dependency for to-do business service. And we are directly instantiating a dependency in the to-do business service. So this is good. Now let's check whether the business logic that we wrote is working as expected. So what I would do is I'll go to the test. So I'm inside now the test. So I would say to-do business service business. I'll create an instance of the business service first. And now I'll call business service dot retrieve to-dos related to Spring, and let's say I pass in 28 minutes, or I can pass in mine, and I'll assign it to a variable. Now, I would want to make sure, so the data service is returning how many? The data service is returning 3 things, but out of which only one is related to Spring. So that's the only one which should be returned back. So I will assert, so in the test, if you are unfamiliar with JUnits, assert equals compares the expected value versus the actual value. What we have is we want the list of things which are related to Spring returned back. So out of the to-dos, only one is related to Spring. So I want to check whether only one is returned back. So expected value here is 1. So I want to check that the to-dos.size is 1 after the business service returns it back. So I would go ahead and add in the static import assert equals. So now if I run this test, let's see what happened. So it succeeds. So what we see here is that the to-dos.size is just 1. So I'll also check the first element whether it's the right one. So the first element that we are expecting is learn Spring, because this should be the only thing that should be present in here. Learn Spring, comma, to-dos dot get of 0. So the first element in to-dos should be learn Spring. You can do a right click run as JUnit, and there you see the green bar. So everything's working fine. So what's happening here is that we are calling the retrieve to-dos related to Spring, and it is calling the dependency, that is the data service, and it's getting the values, and we are fine. So we are all working fine. We see that it's getting the correct values, and we see that our tests succeed. But so what we have right now is typically how the scenario was when we were developing applications before Spring. So before the Spring framework came in, we used to have very tightly coupled stuff. If you look at the current implementation of the whole thing, the to-do business service test is creating an instance of to-do business service. The to-do business service is directly creating another instance of to-do data service. So the to-do business service is tightly coupled with to-do data service. Also, the to-do business service is taking the responsibility of creating the dependencies on itself. This is exactly how applications were developed before the Spring framework came in. We used to have very tight coupling between classes, and it was very difficult to write very good unit tests. During the next section of this tutorial, we would look at how to eliminate this tight coupling and how Spring framework brings in the magic of dependency injection and helps in making the entire application loosely coupled. We have now developed a business service, to-do business service, which is tightly coupled with the to-do data service. And after I have implemented this, what happened was the database went down. So whenever I tried to make a call on the database, what's happening is this. I'm kind of simulating the database down here. The database went down and I can no longer retrieve the data from the database. So if I run this right now, I would get a failure. So you would see the red bar for the first time. So it's showing a red bar because the database is down and I can't develop any longer. And as a good developer, I don't want to write code without really testing it. So I don't want to write 1,000 lines of code and test all of them together. So how do I solve this problem? How do I really be able to test the business service which I'm writing? So my focus here is I want to focus on writing the to-do business service. I don't really want to care about what the data service is doing, whether the data service is talking to a database or an interface. I don't really care. But what I want is the to-do business service. As I write code in here, I want it to be tested. So I want to write 2 lines of code and I want to test whether it's working fine. And that's not possible right now because the database is down. So the solution which is possible is to create a stub. So what we do is, instead of using a to-do data service, what I would do is I would write a to-do data service stub. I mean, some people create mocks. That's okay. I mean, as far as just tutorial is concerned, I don't really think we should make a lot of distinction between stubs and mocks. There are frameworks like Mockito which help you in creating very good mocks. But for now, let's keep all that conversation away. Let's focus on creating our stub. So I want this stub not to talk to the database. I don't want to talk to the database in this stub. What I want to do is return some dummy values back. So now I have a stub. Am I good yet? So what I have is I have a stub for the data service. Am I already good? Can I run this program and will it succeed? Let's check. Right click, run as JUnit test. Nope. It doesn't succeed. It still says database down because the to-do business service is still referring to the to-do data service. It's not referring to the to-do data service stub. So I would want to change this to to-do data service stub. Oh, that's right, to-do data service stub. This side. So it should be to-do data service stub as well in here. Now the to-do business service is really talking to a stub instead of talking to the real data service. Okay, we are back with the green bar and now I can continue development and I can start working with this. So I can now start developing with this stub and continue working on my business service, and I can make progress with my. What happened is I now deployed the code to the server, and there are complaints that I'm only getting one task related to Spring, whereas I have 5. This is because we are still talking to the stub, and we are like, when I deploy on the server, I don't want to be talking to the stub. So when I deploy on the server, I would want to be talking to the real data service because I would want to get the data from the database. But when I'm running the test, I would want to talk to the stub. So that's where the complexity is. So to be able to run the unit tests, what I want is I would want to be able to talk to the stub. So this data service stub is what I want to talk to. But when I run the application as part of the web application, then I would want it to use the to-do data service. That is what I would want to be able to do in a real testable application. And each time I don't want to make these kind of changes in the to-do business service. And that's exactly the problem that we are going to solve using loose coupling and the Spring framework. So how do I really make the whole thing loosely coupled? The first thing I would do to make it loosely coupled, the first step, if you look at right now, I have to make 2 changes. So I have to change the implementation and I have to change what implementation to use as well. So can we make it simple? Can we make it at least down to 1 change? And that's where the interfaces come in. So what I would do is I would create a to-do data service as an interface and not really as a implementation. So what I can do is I would say instead of class to do data service, I would say interface to do data service, and I would create an implementation. So I would say class to do data service IMPL, or let's call it real IMPL, real implementation. I mean, usually you won't do this. This implements the to-do data service interface. So now, if you look at it, I have a to-do data service real implementation, which is implementing the to-do data service. And I'll also upgrade this stub to do the same thing. So I'll say implements to-do data service. I have to make the method public because it's the interface, and I have to have the class exposing that method as well in a same visibility. So now we have a to-do service stub implementing the to-do data service, and the to-do data service real implementation, implementing the to-do data service as well. So now what I would do is I can go ahead and instead of, so if I want to connect to the database, I can use the real impl. So when I say is equal to new real impl, it talks to the database. And when I say stub, it would talk to the stub and it would return it back. But still, now we have eliminated the need to change this variable, but we still have to change the implementation. So we have now made it loosely coupled because now the to-do business service is dependent on the interface and not the implementation as such. But still, we have not eliminated the problem with to-do data service stub. And that's where the Spring framework comes in. The to-do business service is still creating an instance of the to-do data service stub. And I don't want that to happen. So what I would do is use the features which are provided by Spring framework. So what I can actually do is I would say I don't want to take care of creating the thing. So this creation of the data service stub or the different thing, I don't want to care about it. Spring framework, can you take care of it? And that's where the term dependency injection comes in. So earlier, this is the dependency. Data service is a dependency of the to-do business service. And the business service was directly creating the the data service it needs. But now with Spring, we delegate that responsibility to Spring. So we say, Spring, you find whichever thing that we would want and you give it to us. And how does that happen? Let's look at it right now. So now I want to make Spring give this to me. So how do I tell that Spring has to give this to me? The magic is a statement called auto wired. We'll understand a little bit more about auto wiring a little later. You can kind of think auto wired as the magic glue. So as soon as I put auto wired on something, Spring would try and find the correct implementation for it and it would return it back. At auto wired data service, now Spring would find the data service and give it to it. How Spring does that? Let's not worry about it. We also need to tell Spring that I would want to auto-wire what? I would want to auto-wire to-do data service stub. So I would want to wire in the to-do data service stub. So I would go to the to-do data service stub and put another annotation. This is called a component or a service. So let's use component for now. Let's not worry about what is the difference between component and service. Let's use component. When I say something is a component, then Spring knows this is particular. So to-do data service stub is a component. So now Spring knows, okay, this is available. So whenever there is at auto wired, what Spring does is it looks at to-do data service. So to-do data service is an auto wired and to-do data service stub is at component. So this is a component. So what Spring does is to-do data service stub is also implementing to-do data service, and to-do data service is the variable in here. So as soon as it sees this component to-do data service stub, what Spring does is it populates the data service with an implementation to-do data service stub. This is what is called auto wiring. So auto wiring is basically the process where Spring scans through the components. So it goes through the list of components and finds which is the appropriate one to use here. So for this to-do data service, there is only one component which is matching right now, which is the to-do data service stub. So because that's the only one which has an add component tag on it. So what Spring does here is it takes the to-do data service stub and gives it to the data service. The other thing we would also want to do is we don't want Nav to take the responsibility of creating the business service. So we would also want to make this at auto wired. Now we are telling Spring, you take care of creating this. But if Spring takes care of creating that, Spring has to be able to find it. And that's why on the to-do data business service as well, we put the annotation at component. So basically what we have done is we removed the new to-do data service stub from here. we want Spring to take care of injecting everything in here. If we want Spring to take care of injecting a data service in here, we have to make that particular thing as add component. So Spring kinds of manages this particular, the instances of this particular bean. And what do they need? They need the data service. So the data service, we want it to be provided by Spring. And that's why we put the tag at autowired. So we are saying at autowired. So autowire this. And I went to the to-do data service stub and put component on it as well. And the other change which we made is we made the business service as at autowired as well. So these are the 4 changes that we had to make. Now let's see how Spring does the magic. So now I say right click, run as JUnit test. Does it succeed? It does succeed. So you see now that the Spring framework has taken control and it does the auto wiring for us. Let's look at the log and see how the magic of auto wiring happened. So this is from the log, and you can see here that it's creating an instance of to-do data service stub. So it's saying creating instance of bean to-do data service stub. In the code, we have not created an implementation of this anywhere. But since we put an add component tag around it, Spring creates an instance of this. And that's what we see in the log. So we see that Spring is creating an instance of this particular bean. Further down, you see that Spring is auto wiring from bean to do business service to do data service stub. So what it's doing is it's taking an instance of this particular stub and it's auto wiring directly to this particular business service. So Spring now knows that that's a component, that's a bean which is available, and this is the matching place it can be auto wired in. So it would auto wire it in here. So this particular thing gets auto wired. And similarly, an instance of to-do business service gets auto-wired into the to-do business test because I have put a component over top of it and at auto-wired in here. There are a lot of complexities around at component and at auto-wired, which we would discuss during the section 4 of this particular tutorial. For now, let's be happy that we are able to get a little bit of auto-wiring and at component thing working. Now, let's say I don't want the to-do data service stub. I don't want to talk to this stub, but I would want to talk to the real implementation. What do I need to do? I remove the add component from to-do data service stub and put it on the to-do data service impl. So if I talk to the to-do data service impl, right now, as per the implementation that we have, we should throw an exception because the database is down. So let's see. Its database is down. So now, based on the add component, so if the add component is on the to-do data service real impl, we are talking to the database. And if the add component is on the to-do data service stub, then we are talking to this stub. So this is exactly the magic that Spring brings in. So now, based on where the add component tag is in, Spring is either able to talk to the to-do data service stub or the to-do data service real impl. So you can take the sample final example which is present in GitHub. That's basically the file which we have downloaded. This is the to-do business test final. You can take it and you can start playing around with it. So you can move the add component from here to here. And you would see that Spring is directly talking now to a real impl. And if you look through the log, you would see that an instance of the to-do data service real impl is created, and that is what is wired into the business service and not the to-do data service stub. And if you put add component on top of to-do data service to-do data service stub, then an instance of this is created and then the program would run with that particular thing. So to revise what we have done in this particular example, what we looked at is really the concept of dependency injection in Spring. So what we have done is we have created a business service, and even that is managed by Spring because we said auto-wired. And in the business service has a dependency called data service. And by auto-wiring, we asked Spring to start managing this particular bean. And based on whatever component is available. So if this is the component, then this is getting auto-wired. If to-do data service real impl is the component, then the to-do data service real impl gets auto-wired. So without changing the code of any of the classes, so we are not really changing the code of either the to-do data service real impl or to-do data service stub or the to-do business service. We are just changing the add component tag from one class to another class, and we are able to connect to different classes. This is the magic of a loose coupling, the loose coupling which we implemented by using an interface. Since we used an interface, we were able to now auto-wire any implementation of that interface in here. So all that we are saying is, to be able to auto-wire the particular class should be implementing this particular interface. So any class that implements the to-do data service can be auto-wired in here. So when we are running the test, we have add component in here. And when we are running the real implementation, we have add component in here. Is there a way we can eliminate this? I mean, why do I really need to keep changing the add component every time I want to switch between a test and a real implementation? That is exactly the problem that we would be looking at in the next section in real world example. Now, let's take a step back and revise some of the concepts that we have learned in the previous example. The first thing is about components. So we defined a couple of things as add component. Even the to-do data service stub we declared as add component. There is another annotation called add service. So add component and add service indicates the beans which are managed by the Spring container. So we are not explicitly creating these beans. So we don't really do new to-do data service stub anywhere. What we do is we kind of give a auto-wired annotation. So we gave an auto-wired here, and this auto-wired Spring would match this component to that. So Spring manages these beans. So when we put an add component annotation against a class, then we are asking Spring to manage this bean. So Spring would create an instance of this particular bean and it would start managing it. These are what are called components. Spring needs to be told where to look for these components. This concept is called component scan. So this component scan is how we tell Spring to look at this particular package. We are saying look at com.in 28 minutes and scan all the classes for components. So what Spring Framework does when it sees this component scan is that it scans every class in this particular package for whatever beans are tagged with add component or add service. That is called a component scan. So component scan is basically something where Spring starts looking for all the components. So whichever packages which we list in the component scan, Spring searches those packages for components. And inside these components, they would have dependencies. So this component has a dependency data service. So when Spring sees a particular implementation of that particular service, Spring does something called auto wiring. So Spring takes that component and wires it in here. This concept is called auto wiring. Auto wiring is basically once Spring looks through all the components, it tries and finds the right match for the dependencies of components. So this component has a dependency data service. And this data service exactly matches the to-do data service stub because it also implements the same service. So it is auto-wired in here. This is called auto-wiring. So these are a few of the very important concepts in Spring Framework: components, services, component scan, and auto wiring. The part of the Spring Framework which takes care of all this stuff is called Spring IOC container. The Spring inversion of control container takes care of the auto wiring, doing the component scan, and making sure that all the beans are auto wired. We got the earlier example working, writing everything in the test code. But this is not really how we do things in the real world. So what we'll do now is we try and move most of this source code to the place where it has to be. That's in the source main Java. Source test Java is usually the folder which contains the test code, and source main Java is the folder which contains the real source code. And a lot of the things that which we wrote in here are really source code and not really test code. So what I'll do is I'll actually copy the entire stuff. So I would copy everything except the test. So Eclipse has this beautiful feature where I can actually do a Control X. I'm cutting the whole thing out. So the only thing which is left out in here is the test. And I'm going to source main Java. I'm going there and doing a right click and paste. And you would see that there are a number of classes which would be created. So now I've moved the code to the source file. What I'll do is also separate each one of them into their own classes. So I'll again paste here. So database is created now, and I would again go to the database to do the business service and do a Control X and do a Control V here. Let's resolve all the errors a little later, but the first thing is to actually make sure that each one of these is in a separate class of their own. So let's first do that. Business service, is there anything else remaining? The to-do data service stub, actually this is the only one which should be in the test, because this is a stub. I don't really want it to be in a source folder. I would want it actually to be in the test folder itself. So let's quickly look at the files. There are a lot of compilation errors. Don't worry about them for now. We'll resolve each one of them. So to do business service only contains the business service. Database, compilation error, but it's fine. Okay. And that's fine. So we have a list of compilation errors, but at least now we have the files in the places where we want them to be. So we have 4 source files and 2 test files. So this is fine. First thing we would try and do is group them into proper packages. So database, I would give it a let's decide the package name for each one of them. So we have the test in the package example1. So let's take this as the base package. So that would mean that I would put the database in a package, let's think, dot database. So this is the package where I would want the database to go. So I'll move the database to that particular package, and also a class should be public. So I'll make it public, and I would want to import the utility list. So I hope there are no compilation errors in here. So there you go. The database is ready, and let's close it. Let's move on to the next one. I would want to do the data services. So I'll start with the interface. So this should be public interface, and I would want it to be in the package. This is a data service. So I'll say data service, and this is the interface. So I'll put the package API and package. And if you do Control+1, Eclipse gives you the option to move this to the right package, and I can import the list as well. Control+1 again. So now the to-do data service is ready. So now I'll go to the to-do data service real impl. I'll make it public, and it's automatically importing all the stuff that we would need. That's really good. The only other thing I would want to do is also make sure that the package which is used in here is right. So this is data service, but this is an impl. So I'll move it to the package impl. Yeah, compilation error. So I'll move it there, and I would import the list. And the last error which remains, it says this method is not visible because it does not have public on there. So I'll make it public as well. So the database retrieve todos method, I'm making it public. So now you have the next class compiling. To-do data service real impl is also compiling. So let's quickly see how to get the rest of the classes to compile as well. So let's focus on to-do data service stub. So this implements to-do data service. That's good. I would want to first look at the package. So this should be in data service. This is a data service and this is a stub for the data service. So I'll move it to the package data service stub and I'll move it down there and I would import the list. So to-do data service stub is also ready and the to-do business service, let's look at it right now. Let's organize the imports and to-do data service, import it, list, import the util, and let's declare the package for this package dot, this is a business service, so I'll put it in a business service package and I'll move it there, and this compiles as well. And the last one is to look at the test itself and make sure that it is able to import the to-do business service. One thing you can check is that every class is public. So this class was not public and that's why you would not be able to see it from here. So now I've fixed that and I would do the import. Let's also make sure that the method is public. That's it. So we have a compiling thing now, right now. So let's see, let's get an overview of the whole thing. So what we have done is actually now we have moved everything into a package of its own. So we have a database. In the database package, ideally there won't be anything called a database. This is just kind of a mock for the database. I didn't want to really connect to a real database. So we have a data service API, a data service real impl, and we have a business service, and we have a business service test, and also we have a data service stub. So we want to be able to run the business service test. Let's look at the to-do data service stub. This is a component. And also when I am in the real world, this would also be a component. You would put a component at all the things that you would want to be a component. So now when I run the business test, what would happen is that the business service, it would be auto-wired from the to-do business service, which is here. Ideally, I should have created an interface for to-do business service and created an IMPL to-do business service IMPL. I have not done that because I'm lazy. We would do that in the subsequent examples. For now, this is a class and this is directly used in here. But this class has a reference to the data service interface. So this is the interface to do data service. And actually, there are two different implementations for this interface, the to do data service stub and the to do data service real IMPL. So what we are doing now is we are doing a component scan in here for com.in 28 minutes. So everything in here, when I'm running the test, the source code is also available. So everything which is in com.in 28 minutes will be scanned and will be available. So the real IMPL and the stub, both of them would be available. And let's see what happens. You're getting an error. If you look at it, it would say something like expected single matching been, but found 2. What is happening here is the fact that for the to-do business service to run, it needs data service to be injected. Spring is trying to auto-wire this, but it is finding two different implementations of the same thing. So it sees the to-do data service real IMPL and the to-do data service stub, which are both implementing the same data service. So it does not know which one to pick and it throws an error. So the way we would solve it is actually that when we are running the test, when we are actually running the test for a business service, I wouldn't want to use the real data service. I would want to use only the stub for the data service. So what I would do is alter the component scan. So what I would say is I don't want to really scan the entire com.in 28 minutes space. All that I would need while I am running the test is scan the business package. So this is the business service package, and I would scan also the stub package of the data services. So now I've changed the component scan to look at the business service package and the data service.stub package. So I'm only looking at this package and this package. So now to run this test, I need business service to be auto-wired. And the business service has a dependency on the data service. And I would want to use this data service. So now I would say data service.stub. Now I run this. You would see that the test succeeded. And if I actually use data service.impl, it will use the real implementation. And you would see that you get a message database is down. So this is now using the real implementation. While running the test, I don't want to use a real implementation. So while running the test, what I would do is I would use this stub. So always in a test, I would use a stub. So this is how the test would look like. So now it makes use of this stub class and everything is fine. Now, when I run the real application, what I would do is I would give the component scan as com.in28minutes. When I run the real application, I mean, let's say this jar is part of a big var where we are running it and the component scan is com.in28minutes. What would happen is the test file will not be available at all. So the stubs which are in here will not be visible to the var file because the test files are not really part of the real executable. So whether it's a var, whether it's a EAR, the test files will not be visible at all. So if I do a scan on com.in28minutes, it would scan the business service, it would find the data service real IMPL, and Spring would auto-wire all of them together. So when I'm running in the real world, in the real production scenario, what would all be executed is the code in here. And so it would tie up the business IMPL with the data IMPL, with the real data source and all that kind of stuff. When I'm running the test, however, since I have specifically mentioned the packages to scan, it would scan only those packages and it would auto-wire whatever stubs which we have created. And so the test would make use of these stubs. This is how Spring is used in real world projects. This is the power which Spring brings onto the real world projects. Now, what I can do is I can keep running this test without a problem and I can keep changing the business service business service class. So I can add more methods in here, code as much as I need while the database is down, and once it's back up, I can really connect to the database. So Spring, the main reason why Spring is framework in the enterprise scenario is because it helps in developing testable applications. And whatever we have right now is a very good step towards building a testable application. Hope you had a good time learning Spring in this particular tutorial. You will find more examples about dependency injection, inversion of control, Spring modules, JDBC, aspect-oriented programming, MVC, and a lot of that kind of examples on our Git repository, as well as links to a number of video tutorials. You'd find a list of more than 10 videos which you can look at to understand Spring even more on the GitHub repository. What's stopping you? Just go down there, look at all the examples and become an expert on Spring. And by the way, do not forget to subscribe. Until next time, bye-bye.